Algebra Lesson 7-1A. We spent a lot of time now dealing with equations, solving equations, graphing equations, even inequalities and graphing inequalities. And today, for the first time, we're going to actually start looking at a situation where we have more than one equation at a time and some of the different things that we can do with that. So specifically speaking, what we're talking about now is what's known as a system of equations. So it's still equations, still going to have an equal sign, still has variables, but the difference is we now have two or more. So you could have 3 equations, 4 equations, 5 equations, where most of our time we're going to spend dealing with 2 equations, but it could be more. So that's what we refer to as a system of equations. Now, in order to find a solution, we've spent a lot of time finding solutions for one equation. Now we got to find an answer that'll work, that means an x and a y, that'll work in both equations. So we're looking for one very specific ordered pair. If you think about it, this equation right here has an infinite amount of possibilities that are answers to it. And this equation over here has an infinite amount of possibilities that are answers to it. What we're trying to find is the one that they might have in common. That would be the solution to the system. Alright? And it sounds daunting because you're like, man, there's so many possibilities, but it really isn't that bad once you know some of the key things. So here are some steps that we can use. This is one method that we're going to especially kind of focus on right now. The 4 steps to solving a linear system by using a graph. We are pretty good at graphing equations at this point. We have a number of ways we can do it. Input-output tables, slope-intercept form, standard form, x and y intercepts. We have a lot of different ways we can graph, and we can use any of those methods to do this. So here are the 4 steps. Number 1, you want to rewrite the equations so they are easy for you to graph. Whatever is easiest for you. If you're easiest with an input-output table, then use that. If it's easiest for you to use slope-intercept form, then use that. Your job is to do whatever you have to do to make it as easy as possible for you to make the graphs for those equations. That's number 1. Sometimes you won't even have to do much. It might already be in your favorite form, and then you're good to go. Second step, graph both the equations on the same coordinate plane. You're not interested in graphing them on 2 different coordinate planes. They've got to be on the exact same graph, so you're graphing them in the same location. Step 3, take a look at them and estimate where you think the 2 lines cross. Because if you think about it, this line is an answer, dot, 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 dot. Every single dot on that line is an answer to one equation. And this line, dot, 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 is also all the answers to the other equation. Where they cross is the one location that they have in common, that they share. So you want to estimate that. You might not be able to tell exactly what it is, so you estimate it. And once you've estimated it, then you check the coordinate in both of the original equations and see if it actually works. If you can take that answer and plug it into both equations and it works, you know you have the solution for the system for both equations. So let's try it out a little bit here. We'll start with some. Here are the 2 equations. 3x plus y is equal to 11. And x minus 2y is equal to 6. Both of these are in basically standard form, or very close to standard form. Maybe you decide that the one over here is good enough in standard form, and you decide to put a 1 in front of it and a plus negative there. So now you truly have ax plus by is equal to c. And there's a lot of information we can get from standard form. If we want the slope is equal to opposite a over b. If we want the y-intercept, that's equal to c over b. And if we want the x-intercept, it is equal to c over a. So anything we could possibly need for graphing is available to us. All right? We try that out. The slope is -1 over -2, which is the same as +1 over 2. So either one of those slopes would work because they're the same. Our y-intercept is the c over b, so that's 6 over -2, which makes -3. And our x-intercept is going to be 6 over 1, which is 6. So I have plenty of information for making the graph for that right-hand equation. This one, just to be different, even though it is in standard form and we could use the exact same relationships, we could add -3x to both sides. And that would put it into a form that we are familiar with, known as y equals mx plus b. And you could say, oh, there's my slope. So they're 2 different equations, and I'm going to do them both in 2 different ways just so we can practice multiple things. All right, the first one over here. This one's in, let's say, green. I've got a y-intercept of -3. So my y-intercept is right here. and my x-intercept is 6. 2, 4, 6. Just to be sure, does it go up 1 and over 2? Up 1 over 2, up 1 over 2. Yep. It would keep doing that. Up 1 over 2, up 1 over 2, up 1 over 2. It'll do that forever. So I have a green line, which I'll change the format of here in just a second. So, properties, we'll make it green. Okay. So that's the green one on the right. Next I'm going to do this one over here, we'll do it in blue. We've got a y-intercept at 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's my 11. And it goes down 3 and right 1, down 3, right 1, down 3 and right 1. Now that's enough for me to make a graph, but since I've already got it here and I can keep it going, I'm actually going to keep going down 3 and right 1, down 3 and right 1, down 3 and right 1. And I think that it's pretty easy to see where they cross. And where they cross is the one answer that both of those graphs have in common. These are all answers to the left equation. These are all answers to the right equation. That's the only one they share. And it appears to be at 1, 2, 3, 4, negative 1. So I think 4, negative 1 is the answer. If we try that out, 3 times 4 is 12, and 12 plus negative 1 is in fact 11. It works. If I stick the 4 in for x, and I put negative 1 in for y, negative 2 times negative 1 is positive 2. 4 plus 2 is 6. So it works. It works in both equations. That is the solution to the system. Alright, let's try another one. Now you have these two. Negative 2x plus y is equal to 2, and x plus y is equal to negative 1. Using standard form exclusively, since they're both in that form, if I want the slope, it's going to be the opposite of a over the b. If I want the y-intercept, it's going to be the c value, 2, over the b value, 1. And if I want the x-intercept, which I don't need, but I can do it anyway, it's going to be c over a, which would be 2 over negative 2, which is negative 1. Alright, similar concept here. This is going to have a y-intercept, or an x. They're going to have 1's in front of the x and y, so our a value is 1, our b value is 1. Our slope is opposite a over b. Our y-intercept is going to be c over b. And our x-intercept is also going to be c over a. That's enough information now. We can make our graph. If I want to, I can spread things out a little bit. I don't have to keep them on this small frame. Could go 1, 2, 3, 4, 5 if I wanted. But I'll leave it. So we've got the top one has a y-intercept at 2, which is right here, and an x-intercept at negative 1, which is right there. And it goes up 2 and right 1 forever, which is enough for me to make a graph. Right there. Arrows on it. And the other one has an x-intercept at negative 1. And a y-intercept at negative 1. And it goes down 1 and right 1, down 1 and right 1 forever. But now we can definitely see where they appear to be crossing is right here. And I believe that coordinate is negative 1, 0. I'm looking for the coordinate where they cross. Try it out. Negative 2 times negative 1 is positive 2. And positive 2 plus 0 is still positive 2. Negative 1 plus 0 is negative 1. It works in both of them, therefore it must be the correct answer. So we've done 2. This one, I used a mixture of standard form and slope-intercept form, but I still look for where they crossed. This one I was exclusive to standard form because that's the form they were easily in. I still look for where they were crossed. I can graph in any order I want. So here's one more to look at. Fish pike are equal to 5,750 and they decrease by 250 a year. So there's currently 5,750 fish. But next year there's going to be 250 less, so there'll be 5,500. And then there'll be 5,250. And then there'll be 5,000. It's going down 250 fish every single year. On the flip side, tuna are on the rise. There's 3,500 of them, but they're going up 500 every year. So the next year there will be 4,000, followed by 4,500, and so on, and so on. So looking at our graph, here's how we would deal with this. The fish, the pike, has a starting amount of 5,750. That's your B value. In any kind of a linear model, the starting amount, the initial starting amount is your B. And over here we have a slope, but it's negative 250 because it's going down by 250 every year. So we have 5,750 for our B. That means y equals negative 250 x plus 5,750. That equation represents all the pike going down 250 every year. Again, we have a starting amount of 3,500 tuna, and our slope is going up 500 a year, so it's positive, which means writing our equation y equals 500x plus the starting amount of 3,500. And so we got to graph those, and we're going to look and we're going to see when is tuna, which currently is lower than pike, going to take over and have more than the pike themselves. So here's 0, and I've got to get up into the thousands here. So maybe I'm better off going something like 500, 1,000, 1,500, 2,000, 2,500, 3,000, 3,500, 4,000, 4,500. That's probably not quite going to make it since I have a starting amount of 5,750. So I need to readjust, and that's okay. I'll keep my increments there. Instead, I'll just make each one of these 1,000. So there's 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000. I got plenty there. Now I got my years across the bottom. I can go 1, 2, 3, 4, 5, 6, 7, 8, 9 if I want for years. That should be enough. Now comes the graphing portion. This one starts at 5,750. There's 5,000, there's 5,500, and there's 6,000. So 5,750's got to be halfway in between there. It's okay to approximate. Now I know it's going down by 250 every year. So down 250 every year means it's going to go down halfway in my increments, each one of these. And now I have enough to start here and go like this with my graph. Now again, this is an approximation, but it's pretty good because of the increments I have. The other one starts at 3,500. 3,500 is right there, but it goes up 500 every year, so it's going up 500 every year, up 500 every year, up 500 every year, up 500 every year, and now I can definitely see where I'm increasing. And it's easy to tell that in 3 years, if I just come down here, in 3 years there will be exactly the same amount of fish. After 3 years, there's actually going to be more tuna, because this is tuna and this is the pike. So tuna's on the rise, and it's going to pass where the pike is.